So hopefully everyone had a great break.
Went skiing.
We're gonna start session C, where we're gonna looking at the output files of TEVA and me and Ryan try to pre-process it, post-process the output files a little bit, and use visualization tools to better understand what's going on. But before getting into the code, let's take a look at a few slides that Ryan prepared, just to show you what we're trying to do here, and then we're going to take a look at the raw output file as well. So what we're trying to do here is that interpreting the raw output files is a little bit challenging, and I'm going to show you why. So we thought, well, let's kind of develop a few functions and an interactive dashboard to better understand the output files of TEVA. Okay, so here is a sample of what raw output file of TEVA looks like. And as I told you, there are two Excel files out of TEVA. One is CC and the other one is DNF. You're looking at the CC here. You can see for our example, we have two classes. So you would have two sheets of Excel spreadsheets, and then you would have each CC in a row, and you would have different characteristics of that CC, like age, order, and those type of things that I'm not going to go into the details about. But the interesting part is here where you have feature name. Here is feature 0, but we can easily replace it with actual feature names from the input file. And you would get some empty cells, which means, oh, that feature is not one of the constructing component of that CC. But you also get in some cells a range of values. And that means that feature is one of the constructing component of that CC, and that's the influential range. So looking at it, it would be a little overwhelming. And I'm gonna go to the next slide. Again, this is for DNF two spreadsheets for DNFs, and here instead of having features, you have CC numbers and 0 and 1. So basically a binary map that tells you is a CC in, for example, DNF number 1 or not.
And then you have to link back to the previous page to know which CC
exactly
they were talking about.
So that would be
a
little confusing and overwhelming. So, but it's a very good thing to get familiar with these spreadsheets in case you want to write your own post-processing functions, or you want to explore other things than what we did here. You had a question?
Yeah, so just to clarify on this spreadsheet here, the CC would be like the combination of features. So these are no longer the individual features.
Yeah, so for the CCs as feature combination, and this one is the okay. So we're gonna jump to the code right now. So I need to, I'm gonna ask Kristen to share the screen, but what you're gonna see next in the, and I want you to open the TEVA bouquet dashboard, Jupyter notebook, and there we are gonna take a look at a dashboard by Ryan. Yeah, let's jump there. Oh, I need to select it here. Okay, we might need Hannah again to.
What do you want to go back to?
I want to share Kristen's screen on the Zoom. I think it's not.
Is she wanted?
Are you sharing your screen, Kristen?
Yes.
I
So you're not having it selected.
What no, you're seeing this one, right? Yeah, that's the issue.
Do you want me to stop?
Oh, how about now?
We see the
Oh,
the
you
TEVA
can
model
switch.
initial run.
Okay,
Right,
that's the screen.
That's what we want. Right?
Yeah.
Okay, good.
Okay.
I'm still seeing that. What the heck?
Really?
Yeah.
There are
Mine switched
multiple
over.
screens being shared. You can switch between which one you're looking at.
Oh, I've never seen that. Thank you.
Okay, so let's open TEVA bouquet. Again, you wanna make sure that you select the right Python kernel up there. So TEVA workshop environment kernel, select that one before running anything. And then you go ahead and run the first cell and the second cell, which are just importing the packages you need for this dashboard, and then also importing the data output file, TEVA output files for a specifically low class outcome. Okay. Is everything working?
Seems to be.
It's okay.
So good.
Yeah. People online can chime in if they're getting any error, but they should work. We tested, me and Ryan tested these node posts a bunch of times. Have you changed your kernel? No. Yeah, change your kernel, run it again. Okay. So let's go to the next cells. So these are only Python codes to prepare the data for the dashboard. So you don't have to understand all the Python code that was written here, but these are needed before kind of showing the dashboard. So you can just hit run on the cells until you see the dashboard at the very end cell. So I'm gonna just run these construct CCs, color maps, fitness, and yeah.
So the
Okay.
dashboard is not coming and the code is running error free.
Okay.
Dashboard means there you should see some visual, no?
Yeah. So um, can you select this one probably? Oh. Have you installed the Python kernel?
Yeah.
No. So we should go back and install the.
Leave it
Python
to the
kernel.
computer scientist to be the one in the room that's having the most trouble.
So we created this.
Now someone has to have this trouble.
No.
PhD computer scientist, I might add.
No, actually he said install the TEVA, but it has installed now.
No, I didn't. Do you have the README file? Could you open the GitHub page? There's a instruction you need to do a couple more steps before being able to run this code.
Oh.
So you need to activate the Conda environment, and then you need to install kernel. So is everyone getting okay, cool. So what you're looking at here is the plot that Kristen showed you, and you can see it's pretty different from the raw output file of TEVA. And what I want you to show you is that I want you to go to the Zoom and where I shared my screen, and you can try this yourself as well, but I can zoom out a little bit. Okay, so if I click this on the legend, if I click any of these, that would turn off those points. So basically, that's a feature of this interactive plot that you can take a look at CCs and DNFs, and you can kind of turn off the higher order ones. And let's see how this is. Okay. Are you trying what I'm doing as well? Turning off the points and see different orders of DNFs and CCs. So as Kristen described, we want the more the lower order CCs and DNFs because that would be more parsimonious. And also that you mentioned another point about overfitting, but yeah, you can chime in anytime if you want to.
Yeah,
that again.
the higher order CCs and higher order DNFs are likely, meaning they have many features in them, they're likely overfit solutions for your problem. So Don, I don't know if you want to say more about that, but I think this is a great functionality of this plot that Ryan has created, you can actually filter out those higher order CCs and DNFs if you fear that they may be overfit, and just focus in on the lower order solutions, at least at first.
I'll just add to what Ryan did is he plotted the lower order on top of the higher order. So if you notice when they were going through the filters, you didn't really see much changing at points. And that's actually a good thing. And that's where you probably are dealing with the overfitness that Kristen was talking about. So gives you an idea of, at which point do you start really losing that fitness?
Yeah, really great point that the way they were plotted, the way Ryan constructed the plot there, the lower order CCs and DNFs are appearing on top of the higher order. But it's a great to have that function to filter out those higher order ones too. And then are you going to show where you hover over one of these?
Yeah, so if you hover over one of these points, for example, what I'm sharing with you right now is I'm on the CC number 71, and it's order 4, and it tells you what features it is constructing of. And right now it says feature 4, feature 13, but these are actually the inputs to the model that can be easily
labeled.
Yeah, labeled with the input data names. And other thing that Ryan wanted me to tell you is that this is pretty preliminary. So he's working on it to update it continuously. And but I think still it is very, very helpful in terms of understanding what's going on. And one other thing that you can do, for example, you can zoom in this right corner
where we're maximizing coverage and
Yeah.
positive predictive value.
So, and you can kind of explore the DNFs as well, and it tells you what CCs is actually building this DNF. For example, here you have 2 DNFs on top of each other. You can see on my screen. So this is panel A of the interactive dashboard. You also have a table there that shows the features constructing CCs, and a plot there that shows the most used features in CCs, and there are 2 tabs on it. One is CC feature usage, and the other one is DNF CC usage. And if you switch back and forth, you can see, for example, what I'm getting here is feature 26 is most used, but
here's where you would then consult with your domain experts, and maybe that's you, like you turn to your other self and say, does that make sense that that feature would appear so often as being associated with my outcome class? And but if you're not the domain expert, if you're just driving the TEVA tool, that's where you would meet with your domain experts and say, does this make sense?
Yeah.
So is the DNF order one the same as the CC?
Yes.
Okay.
that's
Gonna be one of the improvements that we make
Okay.
in the next version.
I think Camden might have had a question in the chat.
Thank you. Yes, Camden, the answer to your question is yes.
What was the question?
He was wondering about the different, in the paper, I labeled these plots with precision and sensitivity, and he was wondering if that's the same as positive predictive value and observation coverage. So yeah.
Well, that's kind of saying, I've noticed all the higher order DNFs plot all the way at 1 on the x-axis, but very on the y-axis.
Yeah,
And that's interesting.
yeah, that is kind of interesting. I mean, ultimately, you do want to be in that upper right corner. Do we want to say anything about the fitness bands here?
Well, the other thing is, Ryan has shaded, and Kristen's original plots, right? Every single one of those lines was a contour, and it had a number associated with it, and we wanted the minimum. So you're looking for solutions in that upper right-hand corner, and you could know what the fitness is. He's shaded the bands between them, But in this particular example, it looks like the reason you're getting a lot of solutions down that right-hand side is because the contours can be shaped in different ways. And you'll see that if you were looking for a really low contour, I don't know how to do this without pointing, but maybe I should do it on your screen. So you see how a solution up here will have the same fitness as a solution way over here.
Yeah,
And so it's hard the way Kristen's original output was, especially when things are piled on top of each other, to look for the most parsimonious solution that
yeah,
has the highest fitness. Those are the ones you want to be looking for. In fact, if we could go back to the slides, go back to 2 slides so we can see what the Excel file on here. I'm just doing this because some people might want more control over their own solutions, and
yeah.
now that you've seen what this looks like, which I think is brilliant. If we can't, that's fine. It's just that some of you are probably really good in Excel too, and you might have to do it the way Kristen and I used to have to do it.
Using slides.
That's fine. That's fine. Don't
Yeah,
worry.
still-
That's okay. I can go over that with people who want to post-process it. Don't worry about it all. But you can imagine in that Excel spreadsheet, you would start with, I want the lowest fitness. So you could sort the whole spreadsheet by lowest fitness. And then you would see a lot of CCs, especially if they were piled on top of each other, that all had about the same fitness, but you'd want the ones that had the lowest order. So then I used to resort again by the lowest order. And then there's this importance or sensitivity value that I would then go and look at that. And I would end up just doing kind of repetitive sorting until I found a couple of these good locations. Whereas with this tool, you can find solutions that are pretty good and start there, perhaps. I don't know, there's a lot of other things to explore in this data set that I don't want to overwhelm folks, but.
Do we have time to get into the sensitivity? I'm curious what that.
Yeah, the way he did the sensitivity, or John, you want to explain it? But I thought that was another brilliant idea.
Thank you, Donna. Yeah, I don't know. You keep hyping me up. But the way it is, for instance, if you had a 4th order CC, it goes through and removes one feature at a time, calculates the new fitness, and then you get the difference in, well, the smallest gap between what the fitness is with all the features in it and the one that is one less. That's, the closest one. And the smaller that gap is, the more likely you are to be overfitting, so to speak, where you're only getting a little bit more fitness, if that makes sense. Easier to show on a diagram, hard to explain.
No, not all 4 of those features that made up that particular clause are equally important.
Yeah.
So you can get a ranking then of those.
So you'd get a sensitivity for each of the features in your CC.
Which in my opinion is a little bit more valuable than what Ryan was trying to show here with how frequently it was used, because it's not necessary that more times that it was used necessarily means it's the highest sensitivity or highest importance, which is why I love this other feature, but you guys don't have that in this version, but you will when we repost it.
And to build off that, and I'm getting deeper into the weeds, but maybe this will make sense later on. Depending on your feature and the number of values it has will greatly impact how often it shows up compared to others. Because if you think about it, a slight variation in that feature value range will basically give you the same fitness combined with all the other features being equal, but it will be slightly different. So, and Kristen did a great job of doing that iteratively, and I think they're going to show some of the steps later on to help mitigate any one feature becoming too powerful.
We might have a second little online meeting because Kristen and I are pretty brain dead this week. But yes, and those of you, we were talking about my geostats class, I don't know if the error variance that we use in geostatistics, and remember I said you could see how much importance something has by removing it and seeing how much that changes your error variance. That's essentially what this sensitivity function is doing. It's removing it one at a time and seeing the importance of that feature if it got removed from the solution. So that, we promise we will post that version to this. But I can't even finish sentences right now. We promise we will give that to you.
Yeah, so don't close this interactive dashboard. We're gonna need it in the next Jupyter notebook that we're gonna run. So now you can play around with it. You have access to this, but now let's open the TEVA output EDA notebook, and again, remember to change the Python kernel to TEVA workshop environment. You're still, can still see my screen, right?
Yes.
So again, let's go ahead and
Run these.
run cells. I defined a bunch of functions to explore CCs and DNFs. Again, you don't have to understand every detail of those functions, but feel free to play around with those functions after the workshop, maybe improve them as you want. Those are all yours to use. And let's go ahead and run this cell with the functions and go to the post-processing of TEVA output files section of the notebook. Just let me know if you're getting any error or if everything working fine. Are you able to run? Okay. So let me know if I'm going too fast, but the next step would be just to read again the output files of TEVA, and there are a bunch of Python codes there to prepare the data to be ready to be fed into the functions. And again, you don't have to worry about those. Those are just changing the, for example, name of a column or replacing the feature 1, feature 2 with the actual feature names. You can again hit run on that, and we get to the exploring the CCs section. So since we worked on the low class in the TEVA bouquet dashboard, I commented out the high VOC class here. So there are a bunch of codes that you can see there that are related to high VOC, and we're gonna only look at the low for now, but feel free to uncomment those and take a look at them. So the first line is what it's simply doing is just filtering out CCs based on fitness value and keep only the CCs with good fitness. So it's a good idea to take a look at the fitness distribution before setting a threshold here, but I already checked that, and maybe 5 is a good threshold for now. So after also there is an order threshold. So if you don't want high order CCs, you can just say, oh, just give me 5 and below or 4 and below. So it's none right now, but we can change that as well. So once you did that, you can go ahead and plot the CC mask. So what the CC mask is giving you, and you can see there are a lot of CCs. So maybe you want to go ahead and change the order threshold to, for example, 4, and run it again. Still too many CCs, but that's a good thing. So you can see on the x-axis the actual features that we inputted to the TEVA model, and what this mask is presenting to you is just simply to look at that Excel file that we had, where we have empty cells and ranges of values for the features that are actually constructing a CC, and it tells you, oh, if a feature is present or not present in these top fitness CCs. So for example, you can see organic fraction is pretty important, right? But it's we are just saying it qualitatively. So later we can just use feature sensitivity to make sure that it's true, but we can see, for example, soil depth, plateau is present in many CCs as well. So those are important. And again, you can do this for high as well, high DOC class as well. The next cell is, what it is doing is it actually extract those features and the important ranges and plot them. Here, you can specify how many CCs of that list you want to be plotted. So here, for example, I said only plot CCs of, only plot the top 5 CCs. Mean number of CCs features is basically just the order of the CC. If you want to see order 2 and higher or order 3 and higher, here I just selected 1 because 1 is better, it's more possibilities. So if you run that cell and ignore the warnings it is giving you, you can see this plot. What does it tell you? So basically what we're looking at here is the distribution of a feature with plotted in gray, which is the whole distribution of all the data we have. And then the orange line showing the distribution of that feature only for observations that are in low class. And the blue highlighted section is actually the important range of that feature for each CC. So as an example, you can see organic fraction for CC number 21, which is the last one, is 0 to something like 5. But it is different for the other CC, or it's not even present in CC 2020, 22.
That would be like the example Kristen gave of snow depth being present, you know. Some of the CCs, we don't even have snow. They're important in the summer, and in other CCs, they might be extremely important because we're having a rain on snow event, you know, so.
Yeah, and then another interesting thing, for example, here is, I think, geological first class, which has the same range of values for all the CCs. So that range is pretty important. So before running the next cell, which is exploring the DNF, is there any question about this plot?
Yeah, can you just describe what gray and orange are again and how they are different?
So we have this data set with low and high DOC classes. And if you look at, for example, look at the 0Q frequency feature, it has a distribution, right, for the whole 91 observations. If you subset those 91 observations and only look at the observations with low class as a target outcome, then that would be the orange line. The gray highlight is showing the distribution for the entire data set for that feature.
Okay, thank you.
And the blue is the range of values for that
The
CC.
blue is the range of values that the TEVA model is telling us is important, and it's constructing that CCs as you saw in the Excel spreadsheets. Okay, so before running the DNF part, I want you to go back to the TEVA bouquet dashboard, and I want you to, let's just zoom in the upper right corner of the plot. And if you're looking at what I'm sharing on your screen, you can see, for example, DNF number 165 has the highest fitness along with this one and this one. So 84, 165, and 162. You can just plug in those values here. One 65, 84, and 162.
How do you zoom on that plot?
Oh, yeah.
Zoom,
165.
165.
like this little box, you select it, and then it'll let you click over the area you want to zoom into. And then just click back onto this, so you're not going to use the zoom in.
Yeah, it doesn't Or combine, I'm using Microsoft Edge, maybe that's why.
It doesn't let you.
I have, oh wait, it just did for a second.
Okay.
It
If you want to
wasn't
go back to
working,
the
no.
original, you just click this refresh and it'll take you back to what it was.
Thank you.
Sometimes it matters
And
whether
it's
your
on TV.
advisor or Kaylin is looking at your screen.
Maybe it's because I'm using a
That's
trackpad and I'm just terrible with the trackpad.
Why if organic fraction was in so many CCs, does it
Does
not
the
even
last
have a
one work?
KD on these
Last
plots? Like there's not even an orange line.
Oh, so the reason it doesn't have, what do you mean it doesn't have the KD? The orange one, the reason it's not plotting the orange one is that there's
I'm surprised the trackpad.
it's about the warning that you were seeing here. There's
Oh.
something wrong with the range of values for that.
Okay.
But that's an issue with the function I wrote. It's not an issue with the output of the model.
Okay.
So I didn't have time to improve that
Okay.
function to.
I'll
incorporate that,
turn
yeah.
my eye.
Yeah.
Not even looking.
But I want to also point out that this didn't happen until we were looking at conversational data. The absence of something, again, remember, if you're mixing time, especially, the absence of a feature turned out to be extremely important in a particular part of the conversation, which that can be tricky sometimes to get your head around, right? Why is this saying I have to have a zero value as opposed to it not existing? Having a zero value was really important in these conversations. It meant.
Okay, so is everyone able to zoom in on the bouquet interactive plot and see the top DNFs? 165, 84, and 162 all, and by the way, I'm just choosing order 2, 3, and 4 of DNFs for now. But those are the ones that has the highest fitness values. Okay, so if you plug in those numbers,
And by highest, he means lowest.
I'm sorry,
The best.
the best fitness values. So if you plug in those numbers, 84, 162, and 165, and hit run, it will take a few moments, but it will plot the same thing that we saw for the CCs. But this time, basically, it's not showing the top CCs with the best fitness, it's just showing the CCs that are in that DNF. And you can see, for example, for DNF number 84, we have, again, organic fraction, we have soil depth Poitier, we have base flow index, and again, you can see the CC plots for these DNFs plotted as we saw for the CC. So, what does it tell us? So here we can see the meaning of equifinality, where you have different combinations of features resulting in the same outcome. So what for example, DNF number 40, number 84, what it tells you is that CC number 3 that has soil depth, organic fraction, and geological first class is giving us the low outcome, is predictive of low outcome. Also, CC number 62, which has geological porosity and geological first class, give us prediction of low outcome. And you can chime in if you.
You said that very well.
Excellent.
Okay.
And I just
Good.
want to point out that this equifinality, the reason Kristen and I got so excited about it is that we've always struggled with space and time. And you often get really good answers that are very different if they are in different geographical locations or the season change. That's when we expect to see this equifinality. I mean, I'm not to say that it doesn't exist in tons of other applications, but genetics was the one that John and I originally explored, and the environmental applications are the ones that Kristen and most of my other students, right, care about.
Yeah, Ian.
That's a good question. So for 84, just for example, so this is saying like if we go back to the logical operators, this would be CC 30 or CC 62 or CC 89.
Can result in the same outcome.
My
DNF
question,
of their ors, or CC is linked by an or
By an
in
or.
a given DNF.
Yeah, that's what I'm
Okay.
saying, yeah.
also on 84, and forgive me if I missed this, you mentioned it, but low prec timing doesn't have like a important range for any of the CCs.
Oh.
And so at first I was interpreting the important range being like, okay, it was used in that CC, but
Yeah, so this I noticed this. This happens, and I know this is just this morning, so. This happens when the range is basically one number. So you don't have a range of values, you have just one number of values that is important for that CC. But it's not showing it on here, but it should kind of give you a line on that, the blue line there, but yeah, that's one of the things that I need to fix.
is that a, Kristen, or
What's the feature again?
low prec timing, is that a nominal feature?
Low precipitation timing is an ordinal number that is connected to the time of year.
So
If I
it's
remember right, if you go to,
integers, 1, 2, like
Yeah.
that?
yeah, exactly. So if you go, all of these features came from the CAMELS data set. So if you go to Ador et al. 2017, they describe all these features and what they mean, and I just don't have it handy to look it up.
Some of them do have very narrow distributions,
Yeah.
so like it's not
For sure.
necessarily it's more just an artifact of the data.
I guess that's maybe some feedback is being able to tell which of these are, I mean, if you're running a U, which are continuous and which are
Yeah,
integer based.
yeah.
Because a KDE kind of just smooths over.
Yeah.
Right.
Yeah, all that being said, these are just our initial attempts to make sense of TEVA outputs, so feel free to do, I mean, you can do anything once you understand the output files. Yeah, hopefully this was helpful for you to better understand it, and yeah, with that being said, I can go to the slides, right?
Go back to the
If there's
slides,
any
yeah.
other questions about the interactive plot or these notebook.
And always
Is there
keep
a lot?
forwarding like
Yeah.
unusual situations, especially to me, because I find this fascinating. One of the things I thought, I'm not gonna bring up, we tried this on a whole different number of examples. But like one of John's first papers was using this to predict the incidence of Chagas disease in homes that had been surveyed in parts of South America, Central America, essentially. Guatemala, but anyway, one of the interesting findings that people hadn't found, and you can imagine they were trying to run logistic regression and all these other methods to find which features are important, and Carlota, who was an expert down there, kept saying, but we know that like mice and chicken are really important. Like she just knew from surveying households for 20 years that that was an important feature, and they would have that on the survey. But this algorithm actually said that if you want to link it to houses that don't have a high incidence of Chagas disease, having 12 or more chickens was important. And John and I didn't understand that, like why 12 or more? And it kept honing in on this range. And we went back to Carlota, she said, oh, because usually people have like 1 or 2 chickens, but if they have more than like 10, 11, 12, they usually put them in a coop. And the coop is then away from the house. And these birds essentially act as a deterrent in the sense that the bugs that bite humans are just as happy to eat chicken. And so it can lead to a lot of interesting solutions. That's okay.
Can we go to the very last slide? Yeah, thanks.
Quick recap.
Tell us quick recap, yeah.
Ooh. We've done that before.
We have a survey that we'd like you to fill out if you could to give us feedback on today's workshop, and there's a link on the last slide, so we'll try and get there, but maybe Sharia can copy and paste it into the chat. And we'd be grateful if you could just spend 5 minutes and fill out the survey. either, even right now, if you like, and certainly in the next day or two.
And Clara,
And yeah, the other important thing that we need to do before we leave today is to stop your server, because otherwise it'll continue to run on the quasi site. So if Clara is available, you can walk us through how to do that.
Yeah, so there's now a really helpful screenshot in the chat as well. So your server would like stop eventually, but it would just kind of like run in the background of Quasi's compute processes. So if you go to File and you scroll down to Hub Control Panel, you'll see an option that says Hub Control Panel, and once you click that, you'll get two options. Stop my server and my server, and you can just click stop my server. It'll think for a second, and then it'll stop, and then you'll have different options, which is like start my server. And so, also if you were working in Quasi Jupyter Hub and you just wanted to switch from like Python to R, you could also use this process to say like, I don't want to be in my Python environment anymore. I'm going to stop my server. You can click start my server again, and you can select an R environment. So it's multi-useful, but for now, we're just going to stop our servers so that it doesn't just time out in the background of your computer.
cool.
Oh yeah. So thank you for the kind words in the chat as well. If anyone else wants to run a workshop using Quasi's compute services, we are here to offer our help with that. And if you guys want to run the TEVA workshop again for like DevCon, Cairo DevCon, we are more than happy to be there for that as well. So
That's wonderful news, and I'm sure we're going to use your services again. And for anyone out there considering using Quasi services, I cannot recommend them more. Abner and Claire have been awesome for us and helped us run this seamlessly today. So we really want to thank them very much.
yeah, thank you guys. It was so interesting to be part of your workshop too. We love to be able to be part of things like this.
We love you.
Love you guys too.
She did a heart.
Oh yeah, you can see the screen.
And nobody minds ending early, do they?
Nobody minds ending early.
I have a question. Will the recording of the workshop be available in the chat?
We are going to make a recording. We're going to post-process the recording to slice it up into the 3 sessions. And we're going to post that on the YouTube channel of UVM's Water Resources Institute. And so I'll send a link around to those who, everyone who attended in the coming days or 2.
I can also get the chat transcript out to you.
Oh.
It might look a little funky because it comes through as like note kind of, like
Yeah.
not like super nice, but it might be really helpful because there's a lot of chats going on.
That would be very helpful. Yes, thank you.
Yeah, of course.
John also put a link to the 2020 EPA paper and said, really helpful to use as a sleeping aid.
Oh.
I put a data analytics class to sleep with that paper, John, so.
I noticed in the TEVA code repository on there that there were documentation pages. Do you know if those have been built and are hosted anywhere, like a read the docs or something like that?
So Transcend Engineering helped us port the code base from MATLAB to Python, and they have their own GitHub page and their own kind of documentation. I guess the best answer is we're working with them to generate a slightly improved version to address a couple things that we're looking for. And then we're gonna eventually just post this on GitHub, I think.
Yes.
Great. Yeah.
And Scott Hampshire in the chat asked if there's any plan moving forward for sustaining this Python package for TEVA in terms of updates and such.
If we get it to GitHub and we have enough of our own students here using it, we will continually update it. But that's one of the reasons we want to have people using this so that it doesn't die the way other programs die.
We will be open to like open source contributions.
I have a question. When I was trying to learn more about evolutionary algorithms, a lot of use with reinforcement learning was coming up. Is there a reason you guys chose not to use that and or are considering using that? Or is there?
So my dream, because I'd love to eventually teach a non-linear optimization course. Evolutionary algorithms could be a component of it. We have an entire course here at UVM, so why duplicate that? But the short answer is the reinforcement learning really wasn't a thing when John developed this code, and it's one of the things I'd love. We'd love to continually improve the code too, but you have to have a graduate student excited about wanting to do that. So if you end up using it and it works for your thing, these are all things that can turn into a whole direction for a dissertation. So that's a great question. Especially with some of the things that you and Kaylin are doing with conversations, that reinforcement component could be really important to this.
Yeah, just to echo what Donna said, if you are interested in getting into the code or want to pick my brain, there are about 5 different areas in this process that could probably be improved upon. That was too much.
These students.
Any more questions online, comments?
Okay. Everyone's filling out the survey? I do this in my class and then I get 20% return rate.
Thank you.
Thank you.
Yeah, thank you all for coming. Thank you all, and be in touch with if you're trying this on your own data sets. Happy to hear.
And thank you to Hannah if she can hear us.
Yes, and thank you to Hannah, and thank you to Clara, and thank you to Sharia for posting things in the chat to keep us moving along.
And thank you, Ryan, even if you're sick.
Thank you, Ryan. He's gonna watch the recording.
Okay.
Cool. All right, well, enjoy the rest of your day.